Good morning, Highline College Engineering 100 students. This is Dr. Laura Worth. I am an instructor at Bellingham Technical College and currently also a part-time instructor at Highline College with you all. I am teaching statics, ENGR ampersand 214, and I was asked by your instructor to record some answers to questions about what life is like as an engineer in the working world. I have over 25 years of experience as an engineer and a research scientist in industry. So I'm going to try to give you some glimpses on what it will be like when you are out working and practicing your profession as engineers, and some ideas of things you might do as you study to prepare so that you can have the best and most profitable time in your career. So I'm going to go through your instructor's questions and answer them to the best of my ability. And I'll admit that I also asked a few friends and family members who are working engineers for their opinions. So I'll try to give them some credit to the answers to the questions as well. So we'll start with question number one. What type of engineering degrees are employers usually looking for? And is there a specific degree that is commonly looked for? Basically, this is a kind of a loaded question because there's a few engineering disciplines that always have some small demand. It may not be huge, but just about every city or regional area is going to have a certain baseline need for the classical engineering disciplines. And those are generally civil to start with. There is an old saying in the American West, in the Intermountain West, in the deserts, that even the smallest town will have a saloon, a post office, and a civil engineering firm. So that may or may not be true in modern days, but it does speak to how ubiquitous civil engineering is. Civil engineers don't tend to earn all the time quite as much money as the others in mechanical, chemical, petroleum, but there is a very steady demand in most cases. That said, even for the steadiest of demands in any given location, hiring and the need for any engineering discipline is going to go in cycles. So there is really, to be totally clear, there is no single engineering discipline in which you will always be able to be guaranteed to find work in a given location at any given time. Civil is probably one of the better ones as far as that goes. After that, it is location dependent and state of the economy dependent. Some of the classic disciplines, chemical, mechanical, and now environmental, are very general. You may have to specialize in the job. You may have to do additional training for any one particular job, but a basic bachelor's degree in one of those three is going to put you in line for some kind of entry-level engineering job in most places. Anything beyond that is going to be a bit of the luck of the draw of the economy. And your decision on what you go into should probably be based on what you like and what you can do well. Because if you like it, you will study more, you will practice more, you will work harder because it will be fun, and you will excel and be more marketable across the board. Things that you might want to be cautious about: multidisciplinary types of studies, some of the newer branches. Material science is still relatively new compared to the other disciplines. Those engineering disciplines will tend to wax and wane more, as will ones that are tied to single economic sectors like petroleum engineering. When oil is hot, petroleum engineers earn more than anyone else. When it's not, they sometimes have to go find work in completely other industries and have trouble finding employment. So the newer, the more niche, the more specialized, the more tied to a given market sector, the more cyclic it will be. So it basically depends on your risk tolerance and how much you like to learn new things quickly. Okay, question number two. Can someone do two engineering careers at the same time, or hold two engineering positions at a workplace, like, say, being an electrical engineer and an engineering manager? So that really includes a bit of two different questions. Can you do two engineering careers at the same time? If you are staying in the technical realm, you're not going into management. it's very symbiotic sometimes to have a mainline job and then to do some what's called moonlighting, consulting work or other types of sideline work that gives you some variety and complements what you're doing in your main job. That said, if your main job is very demanding, you're being paid a lot of money, you might not have time to do anything else. And you should be compensated according to what your contributions and time input are. In terms of management, it is actually very rare, unless you own your own firm or you work at a very, very small firm, to be an active manager and an active technical contributor. The biggest reason for that is the brain steps, the thinking you go through, the skills you deploy day to day on the job are quite different in a lot of cases. Engineering managers are going to be thinking more like corporate executives, corporate owners, seeing the big picture, being far more concerned with money, marketing, trends, whereas working technical professionals, engineers and scientists are going to be more concerned with the details and making sure that things are actually done right. Things stand up, don't blow up, etc. The two work synergistically, and for small projects, you might play both roles. And definitely if you are entrepreneurial minded and you work for yourself, you will do both at the same time. But in a larger firm, it's usually one or the other. So if you like to lead projects, if you feel yourself enjoying project management, you work team projects with your colleagues and you like to be the one making all the phone calls and making sure things come together, you might really enjoy going into management. It usually pays a little bit more. It can be more or less stable. There's definitely people on both sides that earn a lot. If you like a little bit of both, consulting type work, small firms, and eventually having your own firm are the way to go. Unfortunately, in a bigger firm, you're going to have to make a decision. Do you want to stay in the purely technical realm, or do you want to move into project and eventually personnel leadership? They're all challenging. They can all pay well. They can all be very satisfying. But if you're going to work at a big firm, you'll probably have to make a decision at one point or another which way you want to go. That said, even if you feel yourself going into that you're drawn to management, understanding where the people you're managing come from, having some idea of what they're doing is invaluable to being a good and effective leader. Because those people are going to be depending on you to give them information about that bigger picture. They can't do their job unless you do yours. So it's definitely a relationship of equality. So the more you understand them, like say getting an engineering degree yourself and then doing management studies or on the job training, you'll be a more effective manager. So if you're going to manage engineers, it's not necessarily a bad idea to pursue an engineering degree. You will be definitely more effective. And if you're running a small firm or your own firm, make more money. Okay, question 3. Can someone mix engineering with any other field? Absolutely. Absolutely. The first most classical one is to mix an engineering bachelor's with a master's degree in some kind of business management. Computer sciences are another natural fit with engineering. Some of the geological sciences are fabulous fits, especially if you're going into civil geotechnical. Any of the biological sciences will tend to be helpful if you're going to go the environmental route or sustainability engineering route. In fact, there are very few other disciplines that can't help an engineer do her or his job effectively. Even the humanities. Writing practice is invaluable for helping you frame your thoughts rationally and logically and coherently. Very important for everyone. So there's not many that don't help. And that's one nice thing about engineering is it is somewhat multidisciplinary in its nature. Unlike being a pure scientist, maybe that you're always in the lab all the time and you only interact with your data, your experiments, engineers are always facing other people, explaining their ideas, explaining and understanding how their technical work fits in with a client's or other group's needs. So anything that will help you write better will make you a better engineer, both on the technical and the business side. Question 4, how do subdisciplines work? That depends on which branch of engineering you're looking at. Every big branch of engineering has subdisciplines, and the broader the branch, the more subdisciplines. So take mechanical engineering. That's very broad. Many of you are probably learning things right now that are going to lead you to your bachelor's degree in mechanical. You might specialize in part design. You may specialize in heat transfer. You may specialize in fluids and heating and ventilation concerns for buildings, in which case you would overlap with architects, help them with their design work. Electrical engineers, you can do anything ranging from redesigning the power grid to computer design applications and working with semiconductors and very, very small things. Likewise, in civil, you can build buildings, you can build skyscrapers, you can build sewers, you can overlap into environmental and look at waste remediation in the groundwater. Sky's the limit. So when you look at which subdiscipline might appeal to you or which one has the most employment demand, a great place to look would be the professional societies for each of the larger disciplines. So the American Society for Mechanical Engineers, ASME, the American Society for Civil Engineers. Your faculty can get you in touch with local branches and sometimes student branches of those societies. And then you can learn more about the subdisciplines, which ones are in demand, what extra training you need. But yes, there are a lot of them. You will typically choose a subdiscipline as you head into upper division. So depending on which main engineering branch you go into, you'll specialize in you'll usually have a choice of maybe 2, 3, 4 subdisciplines as you head into upper division, junior and senior year, certainly senior year. Number 5, should one get a master's degree in engineering? It depends. It depends on what you're going to do and which branch you're going into and what type of work you're aiming for or hope to get. Generally speaking, a master's degree used to be considered beyond the pale, extra, giving you a competitive edge. Now it's fairly common. So the big divide between whether a bachelor's is enough or you need to make the commitment ahead of time that you're probably going to need that extra 2 years would be, first, are you going into research? If you want to work at the national labs, you want to go into academics, you want to be doing primary front-end research for a large corporation, the ones that still have research departments, many of them don't. But if that's your dream, you're probably going to want to need a PhD, hands down. If you're not going to do that, the benefit of a master's degree versus, say, getting training in another complementary discipline or just getting out into the workplace and getting that experience, it all depends. Again, your professional societies for your main discipline are going to be good sources of what type of training benefits you the most. On-the-job experience is priceless. It can't be replicated in any educational program, no matter how hard we as your instructors try. There is no substitute for experience. So there's absolutely nothing wrong with going out and getting experience. And then if you find you need more specific training, quite often you can work with your employer and have them pay for some of your follow-on training, whether it's a master's degree or specialty training in a particular computer language or modeling type or field testing method. What is not optional for those of you who are going into civil, mechanical, electrical, environmental is professional licensing. So what is probably more of a concern for all of you and maybe some of the other disciplines as well is to aim to take your engineering in training exam before you finish your bachelor's degree. This is wired into many upper division engineering programs. You can't even graduate unless you get it. That's for good reason. The better jobs, the more engaging jobs, the greater variety, the ability to work for yourself and sign off on critical government projects all requires a professional engineer's license, sometimes known as having your stamp, your professional engineer's stamp. There are 2 levels necessary or 2 levels of that licensing, and you need a 4-year degree or a significant amount of experience to even sit the exam for the first to be an engineer in training. You will be ready and prepared, hopefully, and eligible to take that first one when you get out of school with your bachelor's degree, if you graduate from an ABET accredited engineering school. And then if you do 4 years of work experience under a licensed professional engineer, you'll be eligible to sit the principles and practices exam, which gives you your own professional engineering license. For those of you who are not heading into pure research, a professional engineer's license is probably going to be more valuable than any number of advanced degrees that you could get. So take that first. EIT, or otherwise known as the Fundamentals of Engineering exam, should be your first priority before you leave your bachelor's degree institution. Anything beyond that will depend on what you want to do and where you're going to be working. Okay, question number 6. What are the ups and downs of being an engineer? It depends. You're gonna hear that a lot. Probably the biggest one is like we started with, engineering is cyclic. So no matter how secure you think your job is, no matter how bomb-proof your industry is, the global economy is very volatile and will continue to be so throughout all of our lifetimes, I would imagine. So you could find yourself unemployed, no matter how hard you work, no matter how high your performance, what field you're in, how much experience you have, you could find yourself without a job through no fault of your own. And being prepared to switch fields, switch companies, or switch locations, or some blend of the above is part of being any kind of paid worker today, and engineering is no exception. Beyond that, one of the other ups and downs is definitely the high emphasis on communication. You may be a very highly trained technical professional and your manager may not be. And there's always, going to be a little bit of friction between, you and your manager trying to understand one another. That's why we encourage you to learn better communication. You may have to be communicating across an experiential gap. And engineering is embedded in the business world. So there's all of the not so pleasant aspects of having to worry about the bottom line and money. And we are not, as engineers, always financially able to make the best decisions that we would want. So balancing our technological ideals against the reality of what's profitable or what is budgetable. Even in a government budget, a nonprofit still does not have bottomless pockets. So all of these things can be realities of keeping your job, being satisfied doing your job. Abusive work environments exist in every field, which is why we encourage you to get a lot of training, study hard, have lots and lots of valuable skills, so that if you unfortunately encounter a work environment that's less than ideal, you can find work elsewhere where you will be treated as you should as a professional. That may happen to you as an engineer, as it can in any field. You are not immune because you are a highly trained and educated professional, unfortunately. It very well may happen to you on the job. The better trained you are as a communicator and a technical professional, the better you'll be able to handle that. So that's kind of one of the downs. The ups of being an engineer, it tends to pay reasonably well. Not as well as some things, but far better than others. There tends to be a consistent across the board demand. And if you look just across the country, if you are willing to retrain and to leverage your good basic skills and branch out and acquire different specialties, you can usually pick up work as an engineer, even if there's a downturn in maybe what you studied right out of school. It can be very satisfying, very versatile. You have the opportunity to be a bit of a business person and to be a bit of a marketeer. If you go into consulting or you work for yourself, you have all the satisfaction of running your own business. Again, the professional engineer's license is very good if that's the route you want to go with. So there's a lot you can do with an engineering degree in terms of the type of work you would do. Anything from a pure research scientist to a sole proprietorship doing something very hands-on, bordering on craftsman-like. It's good preparation for all. So number 7, what happens if there is a mistake when doing a project in any type of engineering, and how do engineers fix their own mistakes and get over it? Lots of answers. And again, it depends. So step 1, we try to prevent mistakes. Especially in a large firm, there will be principles and practices, operating conditions that make error proofing easy. They are error proofing. They make it easy to error check yourself. You don't have to be perfect. Second, you will work on teams. You will not be the only one who runs a set of calculations. You will not be the only one who reviews a project and assesses its risk. In fact, there may be a whole team of people who do nothing but check work. Quality engineers exist to do this, and people who assess whether or not your design has an appropriate amount of risk. There are whole groups that do risk analysis and assessments. The more inherently dangerous the field you're working in, the larger and more rigorous those groups will be. This is in addition to things like safety factors that are natural components of design and code regulations. If you're in civil and some types of mechanical and environmental, you will not have to design everything from the ground up using your first principles, although it's good to know them. Quite often, the hundreds of years of understanding of how to do things right and not do them wrong will be embodied in a statutory code. You've heard of designing to code. Sometimes this can feel like a straitjacket, like you're just following a script. But what you're really doing is leveraging a legally implementable, backed collection of the wisdom of hundreds of engineers that came before you. So designing to code, building to code, testing to code is one way that you can error-proof yourself. But of course, no one's perfect, no matter how good the system, how good the code, how many quality engineers and checkers you have, a mistake can slip through. What happens? The first thing that engineers need to do is, if you identify a mistake, regardless of who made it, especially if it's a high-risk project where somebody could die, the environment could be contaminated, there could be financial risk, you alert your chain of command. This is not a time to hide or be ashamed or afraid you'll get fired. And in fact, if you try to hide a mistake, that is the number one way you could get fired, if not sued. And depending on who you are and what your capacity is, you could go to jail. If you are a professional engineer, for instance, and you falsify records, you could and probably should go to jail. So of course, you're not going to do that. So that eliminates that whole problem. But first, fess up, alert everyone. It could be complicated. It could be that there was no way for you to get the right answer. Maybe you did a boo-boo, doesn't matter. You've got a problem that is now downstream and needs to be caught or rectified. And beyond that, you will typically be working with a team of people to figure out the best cause and corrective action, which will quite often be the basis for system improvement. You are not unique. If you made a mistake, chances are just about anybody else could have sooner or later. You may find that you have a weakness in your own training that you need to remedy. You need to train yourself a little better. But beyond that, chances are no one could have done necessarily that much better on the average. And you'll probably be front and center working with a team to figure out how to prevent someone else from making the same mistake down the road. In very catastrophic incidences like the space shuttle incidents, Challenger and Columbia, those led to sweeping design changes in the product being built or used. I was personally involved in implementation of some of the post-Challenger changes when I worked on the solid rocket boosters for the space shuttle. And those became part of our everyday work using the changed design that resulted from the Challenger incident, highlighting some weaknesses. The field of civil engineering has changed radically due to some unfortunate designs. And in fact, the system of professional licensing was partially inspired by a historic catastrophic dam failure in Los Angeles. So mistakes are never good. Like, we don't want them to happen as engineers, because people's lives very often are riding on the integrity and the accuracy of our work, but they are inevitable. You will make a mistake. Somebody around you will make a mistake. Fess up, run it up the chain of the command, and then be ready and willing to participate in rectifying it, and then fixing the system that allowed it in the first place, whether it be you as a person needing more training, which is, hey, more training is always good, or a system that made it easy to fail. And there can, mistakes should always, in the long run, lead to better systems and better work. So they should, at the end of the day, be good things in retrospect. So let's see, number 8, why are there so many different types of software programs used for design purposes? Probably because everybody likes a different one and gets wedded to them, and people make a lot of money trying to find one that works a little better or a little differently and to suit other people. And that's pretty much all I can say. Why do we have Autodesk's huge suite of everything from architectural software to fluids analysis, and then the whole SolidWorks suite and CATIA, not to say all the small packages in the open source. Money is a big driver. Some of the larger, more expensive systems are just simply not affordable for small firms or sole proprietors or educators. So many open source versions of large, expensive commercial pieces of software will spring up to meet that financial need. And, you know, why different packages are produced in the first place. Again, there will be preferences, use preferences. Maybe different people have different experience and say, oh, I wish I had a design software that could do X because that really meets my need. Can't find it, commission it, write it themselves, and all of a sudden you have a new company. Some come and go. COMSOL Multiphysics was a powerful piece of multiphysics modeling software that I used as a battery designer in a small battery startup firm. It was very powerful, but very, very expensive. And it was quickly obsoleted by 3 or 4 open source systems that really worked just as well. So a lot of people who used to use COMSOL don't use it anymore, or it's used sparingly. The diehard users use it to the hilt, make great use of it. And in that case, they can make the recoup on their investment. So lots of reasons, most of them pretty good. Number 9, do engineers work a lot of design projects? Absolutely. That will be your workhorse job compared to, say, technicians, technologists, contractors. As an engineer, you will be the one who is envisioning the solution to your client's need, your customer's need. You will be coming up with that primary idea of what to build, what to say, etc. And then other people will work with you to actually build it. Skilled craftspeople, tradespeople, technicians, test engineers, making sure that it was built the right way. But you can pretty much assume design or something closely linked to it is going to be your mainline thing. Which engineering discipline is the hardest to learn? The one you don't like. They're all hard. They're all pretty similar in a lot of ways. The more of them you know, the easier it is and the more fun it is to do any one of them. But really, you can say they're all hard or they're not hard. It depends on your temperament. If you love to write code, computer sciences and IT will probably seem easy. If you love bench chemistry, then chemical engineering and being a research chemist, engineer, material scientist might seem easy. Writing code, being an IT engineer might seem, foreboding. It all depends on you. Never go into a discipline of engineering with the idea that it would be easy, even though you don't like it. Yeah, forget it. That will lead to frustration and probably ending up switching disciplines with a lot of student debt. Don't do that. Go with what you like. And, any advice might be to go with something that is more broad in general and that you can specialize in. So don't niche yourself. If you're uncertain what seems hardest or most appealing, start with basics, things that you would apply to any engineering discipline. And then as something catches your eye or you find yourself really enjoying one thing or another, it may be hard, but it will be fun. So you'll practice more and you will get proficient, and then maybe it won't seem as hard. Another thing to remember is things that seem easy are probably easy for most people and will become more competitive. And that's kind of a supply and demand nature of the beast with any profession. But if something is really hard and you had to work really hard to get good at it, that's a barrier to entry. And it means that you are likely to be paid more to do it, whether as your own business providing services or as an employee looking for compensation. So hard isn't always bad in the business world. 11, do you think that math and physics are very important and all engineers have to be good at them? They are very important. Math especially is the language by which we describe the physical world. It is the most important language that engineers speak, other than a verbal language, probably English. If you don't speak both a regular word-based language and math, you will have a hard time being an engineer. Physics and chemistry go together, and you really need to be familiar with both. You pretty much can't have enough math as an engineer, because the more you learn, the more things you will find that you can describe, the more ways you can see problems, and literally the more fun the field becomes, and the more you will have to offer and be paid to do. Remember, this is a profession. We like getting paid. Do you have to be good at them? It depends on what you mean by good. You don't have to be the top 1/10 of 1% of the population. Do you have to be competent enough to use those tools? Yes, absolutely. Most people are, honestly. If you've made it through pre-calc, calculus, you're taking engineering, physics, and chemistry, and you're doing okay, it isn't overwhelming, you're probably good. If you're doing okay, but you absolutely hate it, you might get some advising and consider another field, possibly. It really all depends on how you like it. Most of us are smart enough to do tolerably well at anything that we work hard enough at. But if that hard work is fun and you enjoy it, even if it's hard, no problem. You'll do well as an engineer. If you can't wait to be finished with your math homework because it just gets to you, you don't enjoy it, maybe have a plan B. If you hate to write, join the rest of humanity, but that will also be a barrier. Math, physics, and writing, all important. Okay, let's see. Last but not least, number 12, what would be your advice to future engineers? Study hard because you're investing in yourself. There are no skills that you probably won't use on the job, whether you're working for someone else or eventually for yourself. Be willing to get every bit of professional certification that you can. It is a crowded world. There are a lot of really good people out there competing with you. That's good for society because we need good engineers, but as an individual trying to earn a living, having more ways to say that you deserve to be paid well will help, and it will give you something to shoot for as you're studying for a licensing exam or some kind of certification exam, in addition to just the grades in school. It's kind of like color belts in karate. It gives you another goal on your way to being a working professional, and will also pay off in getting you work on the other end. Next would be take any and every opportunity you can for real work experience. If you get an opportunity to co-op, a part-time job, doing anything related to the field you think you want to go into, jump on it. That's worth its weight in gold. It doesn't have to be a lot of hours. It doesn't have to be paying much. If you are financially well off, not everyone is, but if you are, and you are having trouble getting your foot in the door for an internship, go out and flog yourself and say, hey, I'll work for you for a month for free for work experience. If you're willing to write a letter saying, giving me a good recommendation, get your foot in the door as an intern, not as a full-time job. Be willing to put yourself forward as you make that transition from your schooling to the professional world. Do not wait for people to come give you a job. As you go into upper division, you will have an opportunity to present at conferences and get to know industry leaders and professional society leaders, be parts of your student professional society chapters. Take advantage of every one of those things. That is priceless networking, to have names of people that you can call and go, I'm going to be graduating. I'm interested in coming to work for your firm in your field. Do you have any internship opportunities? I would be willing to do X. Probably do need to get paid, most of us, but reach out. No one will think poorly of you for putting yourself forward in a professional manner. And speaking of which, any training you can get in resume writing, approaching employers, approaching internship providers, take advantage of those. The modes of professional interaction for job seekers are changing all the time, and they're very different than they were probably when your instructors, including me, were looking for our first jobs. So stay abreast of that. There's a lot of websites for modern job seekers in both technical and non-technical fields. Check them out. The Muse is a good one. There's a million others. Learn what's common. And again, your current instructors and your professional society contacts will help you understand the best way for your field. Some fields of engineering are more conservative and old-fashioned, and others are very avant-garde. And so if you approach would-be employers in a way that they're comfortable with, they'll be more likely to say yes. And if something doesn't work out, especially on an internship, don't feel ashamed. If you get to the end of a summer internship and go, whoo, don't want to do that anymore, good, congratulations. You've just saved yourself maybe a decade of unhappy work. You know what you don't want, and more importantly, you've probably figured out why you don't like it. Now you can train to do something that will take you in another direction. You have to be contributing something of value if you want to get paid, but it doesn't have to be any one particular thing. It just has to be something of value to whomever you want to be paid by. So those are some tips. Everything is changing all the time. Be flexible. Don't get discouraged. If you get a few doors slammed in your face as you're moving into your internship and looking for your first jobs, there's nothing bad about you. Shake yourself off and just say, well, there's a better job out there waiting for me, because there is. And if you identify areas where maybe you need to train a little bit more to have the job you want or work in the area you want, go after it. There's no shame in that. Generally speaking, you will have to learn the equivalent of your first engineering bachelor's degree about every 5 years if you want to stay competitive and have something to offer in the workplace. So you will be constantly retraining regardless of whether you're in a job seeking mode. And that, last but not least, don't stagnate. We all like to rest on our laurels. We're human. But as you move from school into the workplace, it's very tempting to just say, hey, I have an engineering degree. I already know all this. 5 minutes later, it's changed. So take your good learning mode, your student mode, and never stop being a student, even on the job. Always come to work with the objective of learning something new that you could do in another job, or that you could do if you ever want to work for yourself. Don't ever get in the mode of stopping learning, because that's where you will be in trouble and be unable to respond if there's an economic downturn and you need to make a change. So continuous learning, have fun. Hope to see you in the workplace as engineers.